Hi guys, this is the first video for our Unit 2 called This Matters, and the first module in Unit 2 is module number 14. So we're going to start and I'm going to walk you through everything you need to do in module number 14. Each module in this unit is super important to complete because the information builds from the last module. So if you miss a day, it's very important that you get caught up by watching these videos. So here it is, module 14 from Tuesday and Wednesday of September 8th and 9th. Our warm-up is an introduction over matter. So pause the video and do these warm-up questions. Go ahead. Okay, so at the end of this quiz, you should see all the correct answers. That was review about last year. You should have learned the basics about matter, the fact that it's all around us, and it's not all visible. So yes, matter is all around us. Yes, everything we can see with our eyes is made of matter, but no, not all matter is visible. So for example, air is matter. Various gases are matter, but not visible for us. Matter has weight is true, and matter takes up space is true. And of course, you remember that from the Matter song. So just a quick note, we are going to be doing experiments in about a week now. So starting in the third week of September, we'll start with our Oobleck experiment. So please look at this list and buy the things on it that you don't already have, because I would love for you to be doing these things at home. If you don't get these things, it won't affect your grade negatively. It just will affect how much fun you're having. Instead of doing the assignments, you will just be watching me and other students do the experiments. You'll still be doing the work for it. So I'd rather you be doing the work and be having the fun. All right, go ahead and copy these notes. So this is notes, matter, and measurement. This is the third section in the module, which is a link to some notes. So today's notes, we're going to talk about matter and how to measure matter. And our question is, how do we describe and measure matter? So pause the video and copy these notes into your Google Drive. All right, so now that you have your own version of the notes, put in name, period, and today's date. And the first section is that we're going to read an article that introduces us to matter. And while we're reading, we're going to make a list of ways we can describe the properties of matter. So you'll find this article by clicking next in the module. So this says Intro to Matter Primer. So here's our article. It is a Newsela article called Properties of Matter. As you can see, we have many different properties pictured right here. We have different temperature, texture, hardness, if it breaks, color, if it dissolves, if it conducts electricity, if it's shiny, if it has an odor, if it melts, if it boils, if it's magnetic. So these are some of the properties of matter. So you're going to read this brief article, 2 pages. And while you're reading, you're going to fill out just the top section. And I already gave you one property of matter is color. So as you look around your room, you can see matter that's many different colors: invisible, black, white, yellow, brown, green, silver. All of those are properties of matter. That's the color. All right, so I'll get you started, and then I'm going to have you pause and read the rest on your own. So there are many ways to describe a substance or material. Matter, or the amount of stuff in an object, can be described based on certain qualities called properties. Color, odor, and texture are physical properties, though there are many others. Objects can be hard or brittle, which means they break easily. So in this paragraph, we have color, odor, texture, which are physical properties. Objects can be hard or brittle, which means they break easily. So we have some words here. I'm going to fill some out. Odor, texture, And you're going to continue like that. So instead of stopping after 5, because this article contains a lot more than 5, why don't you try to get 10 or 12? So pause the video and read the article and finish that list. Okay, so you should have a nice long list of different properties of matter. So we're going to now talk about size or measurement of matter. So different ways that we can measure matter in science. So this should all be review, hopefully, of last year and other times you've learned about science. You know that there are very specific ways that we measure. So let's talk about some ways to measure matter and the units we use to do that. So this you can find by clicking next in the module. Now in this slideshow, everything that is in green will go in the blanks in your notes. So one of the basic types of measurements in science is measuring length, which of course is the distance between objects. Another type of measurement is volume. So volume is the amount of space that something takes up. And then of course there's mass. So mass measures the amount of matter in an object. So all objects have mass, all matter has mass, and it's similar to weight, except weight is our mass plus the force of gravity. So our mass plus the force of gravity on Earth gives us a weight on Earth. And if we take the same object, like yourself, to another planet or a moon where the gravity is different, your weight can change even though your mass stays the same. So mass and weight are related, but slightly different. Okay, next section of your notes. Here are some other things that we measure a lot in science. Time, temperature, density, which you should remember from last year, and pH, which you might not have ever heard of, but it's another thing that we can measure. Okay, so in America, we use this system called the English system, and it's pretty confusing, especially if you're not used to it. So we use feet, which have 12 inches in them, but then sometimes we use yards, which have 3 feet in them. And we also use miles, which have 5,280 feet in them. Try remembering that number, I can't. We use pounds to measure weight or mass, which have 16 ounces in them. And then we use gallons to measure volume, which have 4 quarts in them. So these unit conversions are all very different and hard to remember and confusing. So we don't use this measurement system in science. In science, we use the metric system. And in the metric system, you only have to remember one number, and that is the number 10. So the SI system, or the scientific system, that stands for System International, so it's used all over the world. It's based on the number 10 to keep it simple and keep it easy. All right, so find this chart in your notes. You have the orange sections are already filled in with the different types of measurement and what we use in America, the English unit. And we're going to fill out the 2 center columns for the metric unit and the symbol. So if we want to measure length, the standard unit that we use is called the meter, and it's denoted with the symbol lowercase m. If we are measuring mass, we measure in grams, which we use the symbol lowercase g for. For volume, it's a bit confusing, but for volume, we use liters. You might remember milliliters and graduated cylinders. And we use that for liquids and gases. And then for solids, so for instance, if I want to measure how much space this block takes up, I can measure the height and width and depth and multiply them together. And so I'd be using centimeters cubed, or cubic centimeters. Now the nice thing is 1 milliliter is equal to 1 cubic centimeter, so it's really the same thing, just two different units that mean the same amount. All right, in temperature, We use the centigrade scale or Celsius, and the symbol is degree symbol capital C. And we don't use Fahrenheit because Fahrenheit is too confusing, too many different weird numbers to remember. For example, the freezing temperature of water in Fahrenheit is 32. Why 32? It just is. The boiling temperature for water is 212. And I only know that because I'm a science teacher. I'm sure you didn't know that. Now in Celsius, it's easy. So in the scientific scale, the centigrade scale, it's the freezing temperature of water is 0 and the boiling temperature of water is 100. So it's very simple and easy to remember. And then if we want to measure time, we're just going to measure in seconds with the lowercase s as the symbol. So these are our metric units and our symbols. Make sure you remember them. All right, and then the last bit of information is that, like I said, the system is based on the number 10. So we can make these units bigger or smaller by multiplying them by units of 10. So 10, 100, 1000, or a tenth, a 100th, a 1000th, and we can go bigger or smaller than that. But let's say, for example, we're measuring something about the size of a house. That's a pretty big measurement. We can use a meter for that. Okay, a door is about 2 meters high, so that's your reference. So a meter would work for something about this size, but what if we're going bigger? What if we're measuring the distance between 2 cities, or if we're measuring the size of a planet? We wouldn't want to do meters. That's too small for that. So we can increase it to kilometers. So the prefix kilo means times 1,000 or 1,000 times bigger. We can also make it 100 times bigger, hectometers. We can make it 10 times bigger, decameters. And then we can go smaller. So down here, we have smaller units. So decimeters are 1/10 of a meter. Centimeters are 1/100th. So century means 100 years. Well, centi means 100. So there's 100 centimeters in a meter. And if we wanted to measure something about the size of a plant, we might use centimeters. Actually, humans, we measure our height in centimeters. So you might be 5'5", and that's 72 centimeters. But then in science, we often measure things that are really small, like a cell, or maybe a hair, or maybe a little insect like an ant. In that case, we'd want to use millimeters. So millimeters are 1,000 times smaller than a meter. And we also can use this for grams and liters too. So we have milliliters, we have milligrams. We measure amounts of medicine in milligrams. We measure liquid volume in milliliters. We can also do kilograms or kiloliters, right? So that's 1,000 times. That's the biggest unit. All right, so that ends our notes for this module. I'm just going to shrink this. You should have the notes filled up all the way down to the bottom. And you can write a summary explaining in your own words, how do we describe and measure matter? So we covered properties and ways that we measure. So tell me something you learned about it in one sentence in the summary. All right, so last but not least, you have an exit ticket today. So use your notes that you still have open and answer these 4 questions, and I want you to get them all right, because the number that you get right is what goes in the grade book. So take your time and submit when you know that you're absolutely correct. Good luck and thanks for watching.